If success is the result that you are ultimately seeking, you must be obsessed with the process. You have no time to let fear, doubt, failure, quit, negative thoughts, or give up enter into your mental. See, you have massive potential. So from the moment you open your eyes in the morning, your mindset has to be win. Meaning winning that particular morning and carrying that winner's mentality with you as you enter your classroom. So what the person to the left of you is pessimistic. So what the person to the right of you is zoned out. You, yes you, can only be concerned with staying locked in because you refuse to let the aura of your classmate or classroom enter into your mental space. See, this race is won by the one that can distance him or herself from the rest of the pack. Those are facts. So I need you to realize that there will be bad days. There will be times that you feel like you have no earthly idea what your teacher or professor is talking about. But what you will never ever do is throw a pity party. What you will never ever do is tap out. What you will never ever do is concede and throw in the towel. What you will do is knock on his or her door and say, listen, I only have one option, and that is success in your class. But right now, I'm confused about the lesson you taught today, and I need clarity, and I need it now. I guarantee you, if you are passionate about wanting to achieve success in that class, he or she will bend over backwards to help you. But if you settle for mediocrity and never say anything, you are setting yourself up to fail, and failure, my friend, is not in your DNA. You're not the first person to question whether or not they have what it takes to achieve at a high level. I promise you're not the first person to feel like they are underperforming. I promise you are not the first person to feel like their brain is about to explode. Listen to me. Those that can push through no matter what storms arise are in the small minority, that small percentile of those that ultimately break through and make their goals and dreams a reality. So the reality is this. You were born with everything you need to pass every class with flying colors. You were born with everything you need to overcome the anxiety that may pop up from time to time on a mission to derail your lifelong hopes, dreams, and aspirations. See, my favorite acronym is HWPO. And just in case you forget, or just in case you don't know, that means hard work pays off. So winners like us never lose focus. And we're horrified and petrified whenever someone tries to tell us to take the easy route. Because we already know there is no easy route. Because if it were easy, everyone would do it. So we avoid that ignorance and get back to our grind of studying harder than we've ever studied before, because we understand that you get out of it what you put into it. So we pour our heart and soul into our homework. We pour our heart and soul into studying for exams. That way we sleep like a baby, because we know in our heart of hearts that we have put every ounce of our being into our work, and therefore success is a foregone conclusion. After all of the hard work, after all of the studying, after all of the blood, sweat, and tears, you still fail. Never forget this. You never fail, you never lose, you only learn. See, life will knock the mess out of you when you least expect it. That's when you have to tell you, because of this setback, I'm strong. Because of this setback, I'm wiser. Because of this setback, I'm smarter. And because of this setback, I'm hungrier than ever. So I say all of this as a friendly reminder. I'm going to be spectacular. So I need you to jump over the obstacles. I need you to go around the pitfalls. And I need you to push through the adversity. Because that dormant volcano of success that's living inside of you is just waiting for you to grant permission for it to erupt.
Today's class will be starting from trigonometry identity. Trigonometry identity. From the word trigonometry, it is simply the study of angles and sides. But our focus in our class today will be on trigonometry identity. Now, yes, if you can hear me and you understand what I'm saying, let me see an emoji. Just drop an emoji, whether in the chat room, in the Zoom, or on YouTube. Just drop an emoji so that I would know you are following. Yes, drop your best emoji. Yes, drop your best emoji. Drop it, drop it, drop it. Yes, I can see. Yes, Abdullah, you're online. You're on Zoom. Drop your emoji if you can hear me and you can see the screen properly. Yes. Then, for the sake of those of us that are live on Zoom, if you can, or if you have any question rather, don't hesitate to drop it. Drop it in the chat room. Certainly good. You can hear me. I can see that emoji there. Good. Thank you very much. Then those online as well. I hope they can hear me too. I hope those online can hear me. If you can hear me, say yes. If you can hear me, say yes. I can hear you. Good. Say yes. Okay, I want to believe those online can hear me. So let's dive into today's class. We have a lot to look at today. Okay, so we will start from introducing the special trig angles. And I'm going to use fingers to discuss this. So, yes, you can see on the screen, you can see the typical finger on the screen. So I'm going to show you my finger. We have 5 fingers. So I will count from the finger down, right? This is 0 degrees. This finger represents 0 degrees. This one, 30 degrees. This one, 45. This one, 60, 90. Let's go 90, 60, 45, 30, 0, 0, 30, 45, 60, 90, 90, 60, 45, 30, 0, 0, 30, 45, 60, 90. Good. So I want to believe you already identified the names of each of these fingers. Good. So with that, when you are looking for the sign of any angle, the formula for it is, you say the sign, you count the number of fingers below the angle. For instance, if you are looking for sine 30 degrees, now 30-degree finger is this one. Yeah. Yes. So, and this is 30 degrees. And how many fingers do you have below 30? That is just one finger. One finger. Therefore, sine 30 becomes the square root of that one finger over 2. Hold on. Okay, good. Over 2. And square root of 1 is 1. Then over 2. If you check in your calculator, we are going to see that sine 30 is 1 over 2 or 0.5. Good. Now let's pick another angle. Let us say sine 60. Sine 60, looking at that, this is our 60-degree angle. How many fingers do we have below 60? We have 1, 2, and 3. Good. So the fingers without the black coloration are the numbers of fingers below 60 degrees. Good. So that means sine 60 will be that square root of the 3 fingers over 2. If you punch your calculator, this will give you 0.8660 approximately. Good. So now let's look at cosine. Cosine of the same 30 degrees. Now let's look at cosine of 30 degrees. Now cosine says the fingers above. So this is our 30 degrees finger. And how many fingers do we have above it? We have 3 fingers above it. 1, 2, and 3. Good. So sine 30 degrees will be the square root of that 3 finger over 2. Then let's look at cosine of 60 degrees. Yes, this is our 60-degree finger. Therefore, since we have just one finger above it, it will be the square root of that one finger over 2. Square root of 1 is 1. Then over 2, which is still 0.5. So now, what do you observe? You observe that the value of sine 30, which is 0.5, is the same value for cosine 60. And why is it so? It is because both 30 and 60 degrees, they are both complementary angles. So in complementary angles, especially when you are dealing with acute triangles, their values are always the same. So pick any two numbers. Let us assume that you pick 50, for instance. What is the complementary of 50? Complementary means angles that you add up together to get 90 degrees. So if you pick 50 degrees, for instance, the complement of 50 is 40, right? So it means that if you say sine 50 degrees, whatever value sine 50 degree give you is the same answer you will get if you press cosine 40. Why? Because they are both complementary angles. Good. So this is not what we want to do today, but it's good you know this because it's going to help you on your journey in trigonometry. So let's move on by answering the question that we have before us. So I'm rubbing the board so that we can have enough space to solve this particular question. If you are with me, say I am with you. Type it in the chat box. Let me know. Say I am with you. All right, thank you. All right. So, looking at this question, we're given that A is 45 degrees and B is 30 degrees. And we are given the formula for sine A. Generally, the formula for sine A plus B is this way. If you are given sine A plus B, the formula says sine A cosine B. Then since it is plus, this place will also be plus. Then it will now switch to now become sine B cosine A. But if it is negative, it will still be the same sine A cosine B, but this time around it will be negative sine B cosine A. Then for cosine A plus B, for instance, it will be cosine A cosine B, then it will switch to become minus. Then you have say sine A sine B. Then for cosine A minus B, it will switch here as well to become plus. So this is the formula to solve identities like this, right? So you have been given the formulas to use here. I want to show that sine 15 is the same as root 6 minus root 2 over 4. And cosine 15 is root 6 plus root 2 over 4. Good. So that is what we want to prove. So let's do this. Yes, I want to rub the board so that I would have space for this question. Okay. Now, we want to show. Okay, no need to say 1 or 2. To show that sine 15 degrees is root 6 minus root 2 over 4. Now, 15 is the same thing. 15 degrees is the same thing as saying 45 degrees minus 30 degrees. Do you believe me? Do you agree? So, now let us assume that if our A is therefore 45 degrees and our B is now 30 degrees. So, since we are talking about sine 15, so we can now put it like this and now say sine 45 degrees minus 30 degrees will now become, so we are now going to apply this formula that has been given to us here. The formula here is, sorry, I want to highlight it. It's sine A cosine B, right? So using that formula now, this will now become sine 45 degrees, right? Then cosine 30 degrees. This is minus, therefore there will be minus here. So the angles will now switch. So this will now become sine 30 degrees, then cosine 45 degrees. Remember, we have agreed that our A is 45 and our B is 30. Good. So now this is where we now need our special angles. So without punching your calculator, we need to find sine 45, cosine 45, sine 30, and cosine 30. Good. So now I will write all those values here, sine 45. Okay, I need space to do that. So let me utilize this space very well. So sine, let me use another color. Sorry about that. I just want this class to be as interesting as possible as we can. Let's make it interesting. Okay, so sine 45 degrees. So this is our 45-degree angle, right? Sine says the number of fingers below it, which is just 2 fingers. So that will be square root of 2 over 2. So let's look at cosine 45 degrees. Now, we have 2 fingers above it, so that will be square root of 2 again over 2. Then, now let's come to 30 now. Sine 30 and cosine 30 degrees. Now, for sine 30, this is 30-degree finger, right? So the number of fingers above, below it now is just 1. So, and square root of 1 is 1. So this will be 1 over 2. Then for cosine, number of fingers above, and we have just 3 fingers above it. So that will be square root of 3 over 2. Yes. I would like to ask at this point, do you understand what we have done? Yes. Asking those of you in the Zoom call. Yes. Abdullah, do you understand? Yes, do you understand? before I move on, yes, I'm waiting for your response. Okay, let me enable you to talk. All right, unmute yourself and speak now. Do you understand what you've done there? Do you understand what happened there, Abdullah? Okay, you're not talking, so all right, you're welcome. Okay. Okay, Abdullah, I want to assume you are hearing me. So
Yes, sir.
let's move. Okay, good. Do you understand what to this
Yes,
stage?
sir,
Do you
I
understand?
understand, of course.
Okay, good, 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 good. So let's, if you understand, so and let's continue. Okay. So in this regard, we are going to substitute the values that we know into this equation. You can see I'm not rushing because I want you to grab everything that we are discussing. So our sine 45 is root 2 over 2. Sine 30 is 1 over 2. Sorry, cosine 30 rather is root 3 over 2. Root 3 over 2. Let me write it properly. Okay, good. So sine 30 is 1 over 2. Then cosine 45 is root 2 over 2. So now let's root 2 times root 3. Since they are not the same root, just multiply them. That will become root 6. So 2 times 2 is 4. Then minus 1 times root 2 is root 2. Then root 2, sorry, 2 times 2 is 4. Good. Now, since the denominators are the same, we can go ahead to subtract our numerator. So this becomes root 6 minus root 2, everything over 4. So, and that is what they want us to prove. We want to prove that root sine 15 is the same thing as root 6 minus root 2 over 4. That is well done, right? So let us now look at cosine 15 in the same vein. cosine 15. So cosine 15 degrees is the same thing as saying cosine of 45 degrees minus 30 degrees. And the formula for cosine is cosine A, cosine B. Our A is 45, our B is 30. It has not changed, so this becomes cosine 45, cosine 30, then minus sine 45 degrees. Sorry, it will now become positive. When this is negative, here will be positive. Then sine 45, sine 30 degrees. So now, let's substitute now. So cosine 45 is root 2 over 2. Cosine 30 is root 3 over 2. Then plus sine 45 is root 2 over 2. Then sine 30 is 1 over 2. So if you multiply root 2 times root 3, that will give us root 6 over 2. Sorry, 2 times 2 will give us 4. Then plus, then root 2 times 1 is root 2. Then 2 times 2 again is 4. And since denominators are the same, we go ahead to add. So this becomes root 6 plus root 2 all over 4. Again, we have successfully shown that cosine 15 is root 6 plus root 2 over 4. Good. I hope you understand. Right? Before we move to the next question. Okay, I believe you understand that. So let's move on to the next question. In this next question, we want to simplify 1 over cosine theta plus 1 over 1 plus cosine theta. And we want to leave our answer in terms of sine theta. Good. So for this one, we write out our question. 1 minus cosine theta plus 1 over 1 plus cosine theta. Now, we need to find the LCM. Now, this is like saying 1 minus x, then 1 plus x. Assuming cosine theta is x, it will look like this. And this will give us what we call difference of 2 squared, which is 1 minus x squared. Right? If you multiply this, it will give us something like this. And since we have agreed that our cosine theta is x, I can say that our LCM here should be 1 minus cos squared theta. But mind you, 1 minus cos squared theta is still the product of 1 minus x times 1 plus x. So why am I saying this? Because in LCM, if we say 1 minus cos x in 1 minus cos square x, we are going to get 1 plus cos x, or cos theta rather, right? So this will become 1 plus cosine theta. Good. Then we'll put the plus here. Mind you, there's this, put this in a bracket. Then if 1 plus cosine theta goes into 1 minus cos squared theta, we are going to get 1 minus cos theta. So I will put it there. Now, since it is addition, opening the bracket now will mean that it will be 1 plus 1 plus cosine theta plus cosine theta all over 1 minus cos squared theta. So let's go. So 1 plus 1 is 2. Then cos theta plus cos theta is 2 cos theta. Then everything over 1 minus cos squared theta. Are you following me? Are you following me? Sorry, I've made an error here. This is minus cosine theta. So this is supposed to be minus and not plus. Good. That is minus. So that cos theta minus cos theta will leave. Right? So we are not supposed to have this there. We are supposed to have only 2 here. Only 2. Good. Now, from trig identity, we know that sine squared theta plus cos squared theta is 1. Therefore, if I make sine squared theta the subject of the formula and positive cos squared theta comes to this side, it will now become negative. So this will become 1 minus cos squared theta. So 1 minus cos squared theta is now equals to sine squared theta. So it then means that at the end of the day, 1 over 1 minus cosine theta plus 1 over 1 plus cos theta, which is the same thing as 2 over 1 minus cos squared theta, will now be the same as 2 over sine squared theta. Right? So because that is what they want us, they said we should leave our answer in terms of sine theta. So 2 over sine squared theta is the result. Is that clear? Now, but if we were told to leave our answer or to simplify, we know from trigonometric identity that when you have 1 over sine theta, this is what we call cosec theta. But if it is 1 over sine squared theta, it will now be cosec squared theta. So now that we have 2 over sine squared theta, we can put it as 2 times 1 over sine squared theta. So this becomes 2 times cosec squared theta. So 2 times cosec squared theta and 2 over sine squared theta, they are the same. Just that 2 cosec squared theta is the most simplified form of the question compared to 2 over sine squared theta, because the question says we should leave it as in form of sine theta. We'll leave our answer here. You don't need to go further to do all of this. Doing all of this is called over syllabus. So let's continue to the third question. All right. All right. Don't mind the way this question was typed. We were told that given that 2 tan A over 1 minus tan squared A, right, is equals to tan 2A, right? Good. So we want to evaluate tan 15 to find tan 15. Now, this is interesting. And do you know why it's interesting? Because 15 is, we don't have, from our special trig identities, there's no 15, but we have 30, right? So we can say that this 2A here represents 30 degrees. Therefore, if you divide both sides by 2, A will now become 30 divided by 2, which is 15 degrees. Now that you know that this is 15 degrees. So we can now say that what is tan 30? What is tan 30? But tan 30 degrees is what? Now, from our special trig angles, we did not look at, okay, I didn't mention tan 30. The formula for tan 30 is the square root of the numbers of fingers below over the square root of the fingers above. This is our 30 degrees angle. This finger is 30 degrees. Now we have just one finger below. This is this finger. And we have 3 fingers above it. Good. So for tan 30, let's do that here. We'll now move the result to where we need it. So we have below square root is 1, above is 3. Now, we need to rationalize because we cannot leave square root below. So you multiply both the numerator and the denominator by the root of what you have in the denominator, which is 3 and 3. Root 1 times root 3 is the same as root 3. And when root 3 and root 3 multiplies, when the square root of 2 numbers that are the same multiply, it gives us just the number, the square root goes. So it means that tan 30 is the same thing as root 3 over 3, right? Are you with me? Are you following? Are you following what we are doing here? Right? Good. Or you can, if you want to leave it in this raw form, you can say root 1 is 1 and root, you leave it like this. So tan 30 is the same thing as 1 over root 3. But because we don't want to leave the roots here, that's why we rationalized, right? By multiplying by root 3 over root 3, you will still get root 3 over 3. Is that taken? Good. So I can put root 3 over 3 here. I'm safe if I put that there. Is that clear? Let me write that 3 very well so that I will not mistake it for something else. So this is over 3. Good. Are you following? Let me rub the board. So now that we know so now let's proceed. Now, if we substitute this into the formula, you remember we're given this formula that tan 2A, right? Hope you still remember. Now recall Don't mind the board is just trying to crash. So recall that tan 2a is 2 tan a over 1 minus tan squared a. Good. And tan 2a, we have said that our 2a is 30 degrees, right? So, and what is our tan 30 degrees? Root 3 over 3. So, permit me, I'll write root 3 over 3 in place of our 2a, right? So, then 2 tan a means 2. Then tan a means what? Tan 15 over 1 minus tan square. Our a is still 15. Good. So let's do some bit of substitution here. So I know I have tan 15 here, I have tan 15 here. So I can say that let tan 15 be equals to x. So if tan 15 is equals to x, then my equation will not change. This is root 3 over 3 will now become 2 times x. Are you following me? Over tan squared is like saying tan 15 times tan 15. So this becomes 1 minus x squared. Now, we are going to come back later to this let's, right? Because anytime in mathematics that you introduce something that you were not given, you are going back to it later when you get the value of your x. So we want to solve for x. Our question did not say find x. Our question is to evaluate tan 15. But remember, it's tan 15 that is x. Good. So now I will now cross multiply and let's see how much space we have to do this. Okay, we don't have much space. So let me create space. So we're going to manage this space. Then if I cross multiply, I will have root 3 multiply 1 minus x squared. Then I will have 3 multiply 2x. So if this multiply, this will be root 3 minus root 3x squared equals to 6x. So this look more like a quadratic equation, right? So let me rearrange it. I will rearrange it by moving everything to this side, move everything here to this other side. If I do that, I will have root 3, then x squared, and this will come here as already I have positive 6x that side, then this will come here as negative root 3 equals to 0. So this is a full-fledged quadratic situation. Let me write the square there very well. The root is covering only 3, please, so mind you. So if we compare it with ax squared plus bx plus c equals to 0, you find out that our a is root 3, our b is 6, and our c is negative root 3. Then if you use the formula, the quadratic formula that says x is minus b plus or minus square root of b squared minus 4ac over 2a. To solve this, then we have x to be negative b. Our b is 6, so this will be negative 6 plus or minus. B squared means 6 squared minus 4. Our a is root 3. And our c is negative root 3. Good. Then all over 2 times a, which is 2 times root 3. Good. So x now is minus 6 plus or minus 6 squared is 36. Then minus times this minus, we turn this to plus. Then root 3 times root 3 becomes ordinary 3. Remember, I said that when roots of the same value multiply, the root will go, so it becomes ordinary 3. Don't forget that. So now that we have done all of that, root 3 times root 3 is 3, and 3 times 4 is 12. Right? Good. So this will be plus 12. Then everything over 2 root 3. So this becomes negative 6 plus or minus 36 plus 12. What would that give us? What would that give us? Yes, punch your calculator. What would that give us? That would give us 48, right? So this will be root 48. Then everything over 2 root 3. Now, I am smiling here because what we did up by leaving our root of 30 as by rationalizing it as made the problem a bit complex, yeah? But all the same, we will tackle it, and I will explain that to you in a moment why that made it a bit complex. I will do both for you so you see the difference. So just relax. We'll get all of that sorted. So now I will move. Okay, let me continue here. So this become minus 6 plus or minus 48 can be broken down into root 16 times root 3. Do you agree with me? Because 16 times 3 is 48. Everything over 2 root 3. So let's simplify further. This will become negative 6 plus or minus root 16 is 4. Then you have root 3. Everything over 2 root 3. So in this regard now, x would now become either negative 6. Let's pick the plus first, plus root 3 over 2 root 3, or x will become negative 6, negative 4 root 3 over 2 root 3. Good. So now let's simplify further now. So what this means is that our x, if I pick this negative 6 over 2 root 3, then plus root 3 over 2 root 3. Here, root 3 we cancel root 3. Then 2 can go in negative 6 3 times. So this will now become 3 over root 3. Plus, of course, this will now be 1 over 2. So by the time you use the butterfly method, 2 times 3 is 6 plus root 3 over 2 root 3. Oh, we are going back. Sorry, if we do that, it means we are going back to where we came from, right? You can see that, okay, we have a negative here. I've omitted the negative, so this is supposed to be minus, right? So this will be minus 6. So please always take note of the sign. Minus. Just be patient with me. The board is acting up. So this become equal to, right? So if you want to write it in a nice way, x is the same thing as root 3 minus 6 over 2 root 3. But I think doing this means we are going back, like I said. So let's leave it the way it is like this. That is 1 over 2 minus 3 over root 3. I think we can leave our answer like that. So let me rub this off. So, like I was saying, you can rearrange it. It can be 1 over 2 minus 3 over root 3. It's fine this way. Or you pick up the other value, right? So this becomes negative 6 over 2 root 3 minus 4 root 3 over 2 root 3. Yeah, root 3 cancels root 3. And then 2 here 1, 2 here is 2. Then here 2 goes in 6 3 times. So this can be written as minus, then 3 over root 3 minus 2. Sorry, put it as plus so that it will affect both of them. So this is our answer, right? Good, but that is the value of x. And remember, we said that let tan x be equals to x. So it means that our tan 15 is equals to x. But however, which of the value of x is it equal to? Remember, the value of tan 15 is positive, right? So therefore, the only valid value is that our tan 15 will now be this positive value, because this one will be 1 over 2 minus 3 over root 3. This one is a valid value for for tan 15. Now, the other part that I was talking about, I said that if we had not if we have not rationalized to get tan 30 as root 3 over 3, and we have left it as 1 over 3, this is what we would have obtained if we have done that. Let me quickly use this small space to show you what I'm saying. It should have been 1 over root 3 equals to 2x now over 1 minus x squared. So if you cross multiply here, you will have 1 minus x squared equals to 2 root 3x. So if you rearrange, everything will become x squared plus 2 root 3x minus 1 equals to 0. You can see the equations are not the same, right? Here we are getting 3 root 3 x squared plus 6x minus root 3. Here you have the equation in a more simplified form, where our a is 1, our b is 2 root 3, and our c is minus 1. So if you put it in the root, you will get a different answer, but the answer you will obtain and the one we obtain are the same, right? So that's the beauty of mathematics. Yes. I want you to solve this on your own. This is an activity. Now you have to solve 2 cos squared theta minus 5 cos theta, right? Can you do this on your own? Yes, write out the question. For the sake of time, I will not be able to do this so that we can move on to the next topic. Then look at this other question. Sine A equals to 3 over 5 and cosine B, right? So where A is obtuse and B is acute, find the value of cosine A plus B. Write this as well. So in your spare time, you can solve this particular question. So let's move on to the next topic, and that is binomial theorem. Binomial theorem. It's a very, very interesting topic, binomial theorem. So, okay. Before we solve this, we would write the general form of the binomial formula. If I have x plus y to the power of n, right? Using the binomial expansion or binomial theorem, we are going to, first of all, take this power here, combine 0, then we are going to say x to the power of this n, then y to the power of 0. Are you with me? Are you with me? Good.
Yes, sir.
Good. So we now have n combination 1, then x. The power of x here will be reducing, the power of y will be increasing. So x will reduce by 1, the power there, then y will increase by 1. Then you do n combination 2, right? X will reduce by 2, right? Y will increase by 2. So whatever you are combining with is what it will reduce with here, and it's what this other one will increase with. So if you do n combination 3, tell me what will it decrease with here? What will it decrease with there? Yes, anybody should respond. What will it decrease with? It will decrease with 3.
N minus 3.
Then this would also increase by 3. So it will go on and on, then till you now have n combination n, then x will now be n minus n, then y will now take the maximum power. Good. So if you simplify further, n combination 0 will always give you 1. If you say 10 combination 0, you will get 1. 1 million combination 0, you will still get 1. So naturally, this becomes x to the power of n, then y to the power of 0 is still 1. So that this can be n combination 1, x, n minus 1, then y to the power of 1. You can leave it as y. Then n combination 2, x, n minus 2, then y squared, plus, I just want to summarize it and just do n combination n will also give you 1. So if you have 5 combination 5, you will get 1. If you do 1 million combination 1 million, you will get 1. So this and n minus n is 0. So x raised to the power 0 is still 1. So by the time you are done with that, you will get this to be y to the power of n. So now, using that same principle to solve this question. But however, before you solve this problem, if this is x minus y to the power of n, we will have the same result, but the difference here for minus is that by the time you combine your results, this will be x to the power of n, then this will be, of course, this is positive, x to the power of n, the next will be negative, n combination 1, then this will be positive, n combination 2, then the next will be negative, then this is where your n combination 3 will come in, x n minus 3, y 3, then positive will come in, on and on, then depending on the number of terms, to now be y to the power of n. Good. So it is this second one we will use. But because I've given you the formula in x plus y to the power of n, we are going to use it, but it will come out naturally as our plus minus, plus minus, plus minus, because our second term is negative 1 over 2. So that will play out in our question. So, mathematics is step by step. That is the ultimate rule in mathematics. It is step by step. So let's apply the formula now. You can also use what we call the Pascal triangle to do this. Now, our question, we really need to do all of this. Read the question. Write down the first 4 terms of the binomial expansion. Now, let me explain terms now using what we have just obtained. Okay, let me use it to write anyway. What are terms? This is the first term. Everything we have here is the second term. Everything here is the third term. Then if you have n combination 3 like this now, this is the fourth term, right? So these are the ones that we really need to find the question. So we don't need to even expand it to the fifth. Now, for it to have power of 5, we are going to have 6 terms. Is that clear? Whatever is the power here, if we have power of 7, it means we are going to end up having 8 terms. If the power is 10, we are going to have 11 terms. If the power is just 2, we are going to have 3 terms, right? And I think Pascal triangle explains that better, right? And let me just give you a glimpse of Pascal triangle. Although we did that yesterday, we applied it in one of the questions. So Pascal triangle is this. It's a pyramid. 1, 1. Then this will be 1. 1 plus 1 is 2. Then you have 1. Then 1, 3, 3, 1. Then 1, 4, 6, 4, 1. Then 1, 5, 10, 10, 5, and 1. You can see it keeps expanding. You use this for the power of 0. You use this for the power of 1. You use this for the power of 2. You use this for the power of 3. This goes for the power of 4. Then this last one for the power of 5. Right? So this would have befitted our question. But because we want only the first 4 terms, we are going to use only the terms from this 1 to 10. So watch out for our results now. Using the Pascal triangle will even help you understand this better. So let's go. So it means that our first term right? Our first term, which is, remember, 2 minus, right? This. So let's remember that, let's take it like this. Our first term will be x to the power of n, right? Is that not so? That's our first term. Where our x here is 2. Is that not so? Remember, let's define our x here is 2 and our y here is, what's our y? Our y is negative 1 over 2x. If I'd known, I would have used a and b so that we don't confuse the x here and the x here together. Good. So, but let's go. So this will be x to the power of n, right? And our n is 5. So our n is 5. Don't forget, our n is 5. Let me write out everything, then we can now apply it. Our n is 5. Therefore, the first term, which is x to the power of n, our x is 2, and our n is 5. 2 to the power of 5 is 32. The second term is n combination 1. So that would be, so let's go. 5 choose 1. Then our x is 2. N minus 1 means 5 minus 1, that's 4. Then our y is negative 1 over 2, right? 1 over 2x. So let me put that x there. That x is very important. Very important. Otherwise, it will alter our results. So let's simplify this. 5 combination 1 will give you 5. If you don't know, it will give you 5. Check it out from Pascal triangle. 2 raised to power 4 is 16. Then you have minus 2 over, sorry, minus 1 over 2. This will be 1 over 2, then x. Now, there's no power here. So, let's process this now. 2 here, 1, 2 here, 8. 5 times 8 is 40, right? But there's a negative here, so I would put that negative there. So that would be negative 40x. So negative 40x. Good. So let's move on to the third term. I hope you're understanding what we are doing. I hope you're understanding. Third term will now become 5 combination 2. Our x is still 2. But this time around, okay, this time around, our n is 5. 5 minus 2, that is 3. Then minus 1 over 2x. Then this will be 2. Now, take note, at every point in time, our powers will add up to give us back our final power. So 4 plus 1 will give you 5. Yeah, 3 plus 2 will give you 5. So don't forget, that is just the logic you will use. Yeah, the maximum power is 5. So your power cannot exceed 5 and it cannot be less than 5. So let's go. So 5 combination 2 is 10. If you don't know, Pascal triangle will tell you. So this is 10. 2 raised to power 3 is 8. Then negative times negative, because here is squared. Negative 1 squared is still 1. Then 2 squared is 4. Then you have x squared. So here your 4 can go in 8 2 times. So 10 times 2 is 20. Then this is x squared. Then the fourth term, since it is fourth term, this will now be 5 combination 3. Sorry about that. So our x is still 2. N minus 3, that's 2. Then minus 1 over 2 to the power x. Sorry. You always look at what you are writing. I think it's because my brain is actually faster than my hands. I keep making all those blunders. So 1 over 2x all to the power of 3. So 5 combination 3 is 10. If you don't know, Pascal triangle will tell you it is 10. So I will advise you to write Pascal triangle down if the degree is not that much. So Pascal triangle will make it faster for you. So that will be 10. 2 raised to power 2 is 4. Then minus in 3 places is still minus. Then this is 1 into 3 places is 1. 2 into 3 places is 8. Then you have x cubed. So 4 here 1, 4 here is 2, 2 here 1, 2 here is 5. Now, the important, why we are dividing like this is because if you do all this division, it shows the examiner that you actually worked it out by yourself and you did not just press the calculator. There's a minus here. Minus times 5 is minus 5x cubed. So this is the fourth term. Now, the question says we should find the first 4 terms, right, in ascending power of x. That is it. So can we combine our results together? Yes. We can combine the results together. Right? So we can say that therefore, right, the first 4 terms, therefore, Sorry about that. I want to take this stuff down. Good. So, therefore, the first 4 terms are, so I'm going to write them together with the sign now. The first term is 32, positive. Second term is minus 40x. The third term is positive 20x. Then the fourth term is negative 5x cube. Right? So that is our, so you can see I is alternating. Plus, minus, plus, minus. The next one would have been plus. Then the last one would have been minus. Because since 5 terms, 5 to the power of 5 means you will have 6 terms. Right? So you would have looked for the 5th and the 6th term. Now, it has a B. The question have the B part. The B part says use your expression in A to find and correct to 2 decimal places the value of 1.99 to the power of 5. Good. Don't mind the board. This time it behaves like that. So let's use it to express. Okay. Are you with me? So I would say to evaluate 1.99 to the power of 5, right? Using the results we obtain, using this result, 32 minus 40x plus 20 minus 5x to the power of 3. Remember, there's the number keeps going on and on, but we don't need all these other parts. This is sufficient for us. Now, let's go. 1.99 is the same thing. 1.99 to the power of 5 is the same thing as saying 2 minus 0. 0.01. Am I correct? Yes. All to the power of 5. They are the same. Why did I choose minus? I can also do 1 plus 0.99 to the power of 5. I will be correct. But you must design what you are doing to look like the original equation, or sorry, the expression given to you. The expression that was given to us is 2 minus, right? 2 minus. So when you are generating yours should also be 2 minus something. If you use this 1 plus 0.99, you will get the correct answer, but in WAEC, your method will be marked wrong. So you only get the answer, the result of the final answer, but you lose the marks for all the steps that you do. So now, I'm going to compare with 2 minus 1 over 2x, right? All to the power of 5. Are you with me? So you can see 2 is 2. Therefore, I would draw the conclusion that negative 1 over 2x is the same as negative 0.01. So negative will cancel negative. So to get x, multiply both sides by 2. Therefore, x will now become 0.02. So now, remember, we want to get the value of, 1.99 using the answer we've obtained earlier. So sorry, I want to move this board down. Okay. Okay, that's enough. So now let's go. Now, I will substitute 0.02 for x into 32 minus 40x plus 20x squared. I omitted squared here, right? Then, yeah, I did not put x squared. Then minus 5x cubed. Good. So I want to substitute these values now. So it will now look something like this. 32 minus 40, instead of x, 0.02. Then plus 20 times 0.02 x is squared, so I'll square that, minus 5 times 0.02. Then x is cubed, so I'll cube that. So are you following me? So if you evaluate everything that you have there in your calculator, don't mind the boards. So we can now say that therefore 1.99 to the power of 5 is equal to, you will get 31.20796. Now, which is approximately 31.21. Our question says we should approximate to the nearest 2 decimal points. So that is it. So that's the result for that particular question. Hope you understand that. Kindly confirm you understand that. We'll move on to the next one. Okay, so let's look at the next question. Ignore the number, it changed where we were doing the other one. This is supposed to be number 2. Now, we are asked to find the coefficient of x to the power of 4 and x to the power of 3, right? In this binomial expansion, 1 plus 2x to the power of n. We're given the ratios 3, that their coefficients are in this particular ratio. I want to find the value of n. Is n we want to look for. So what do we do? What were we given? For the expansion of this, right? Let me write a statement. For the expansion of 1 plus 2x to the power of n, now the general term is or the formula is something like this, where you will say t r plus 1 is equals to n combination r, then you have 2x to the power of r. That's what it is. So the coefficient of x cubed when r is equals to 3 coefficient of x cubed when r is equals to 3 right, will now be calculated like this. So this will now be r is 3 plus 1, and 3 plus 1 is 4, right? So this will now be n combination, right? Our r is 3, don't forget, then 2x, then all to the power of 3. Are you with me? Are you with me? Now, if you multiply 2 in 3 places, you will get 8. Is that not so? So this become 8, right? Times n combination 3. Now, that's the coefficient of x cubed, mind you. So keep that in your right hand. So let's go for the coefficient of x to the power of 4, where r is 4, right? So this will now become t 4 plus 1. All these parts are not really important, so just come n combination 4. So you have 2x to the power of 4. And 2 to the power of 4 is 16 multiplied by n combination 4, right? So given that the ratios of these two, right, are 3 to 1, therefore, we can now say that our, remember, x4 ratio x3 is the same as 16 times n combination 4 x to the power of 4 over 8 times n combination 3 x3. Are you with me? All right, so 8 can go here, 1, 8 here, 2. So this becomes 2 over 1. Then this is n combination 4, x to the power of 4. This is n combination 3, x to the power of 3. So let's keep expanding. So this becomes, let's do it like this. So this becomes 2 times n factorial, right, over n minus 4 factorial using the combination formula now, 4 factorial. Let me do this under because it's a bit, I need space. All right, so let me scroll down. I need that space. Just hold on. The board is acting up. Okay. Okay. So let's go. Remember, this is 3:1. So don't forget that ratio there. So let's go on. So this becomes 2 multiply. Now you know that your formula for n combination R is n factorial over n minus R factorial. Right? Remember that formula? All right, I'm going to write the formula on the board. So this is n factorial, n minus R factorial. So I'm going to use that formula here. Here, our n is n and our r is 4. So it means that if you are doing n combination 4, it will be n factorial over n minus 4 factorial, then 4 factorial. So I'm going to write this here in place of n combination 4. So this will now become n factorial over n minus 4 factorial, then 4 factorial. Right? So this x to the power of 4, you don't need it. And x to the power of 3, you don't need it. Those are just to tell us their coefficients, right? So if I'd known, I would not write them there so that it does not confuse you. That's why I'm explaining all of that. Is that taken? Right? So remember, this is divided. This is divided by, now let us do n combination 3. This is 1 times. So n combination 3 will now be n factorial over n minus 3 factorial, then 3 factorial. Is that taken? Everything is 3 over 1 equals to 3 over 1. So now when division turns to multiplication, this becomes 2 times n factorial over n minus 4 factorial, times. Numerator here will go up, denominator will go up, numerator will come down. This now become n minus 3 factorial, over n factorial. It will still be 3 over 1. So here, n factorial will cancel n factorial. Right? Then, what do we have left? We now have 2 over n minus 4 factorial. Then 4 factorial can also reduce to become 4 times 3. Now, what does factorial mean? What factorial simply means if you have x factorial, it means that multiply x by a number 1 less than x, which is x minus 1. Less than 1 again, less than that number, that will be x minus 2. Multiply by 1 less than that number again, that will be x minus 3. It keeps going on and on and on like that. Is that taken? Good. So we are going to make use of all of that here in the next step that we are going to write. So let me rub this off. Now that you know what factorial means, we are going to apply that principle of factorial now to solve this. Remember, times n minus 3. I want to reduce it by 1, so this will be n minus 4 factorial. Then I have 3 factorial over 1 because this n has gone. equals to 3 over 1. So 3 factorial here cancels 3 factorial here. N minus 4 factorial here cancels n minus 4 factorial. So what do you have here? You have 2 over 4. 2 here, 1, 2 here, 2. So you have 1 over 2 to be equals to, oh, sorry, n minus 2 times, sorry, 1 over 2 times n minus 3. So this will now become multiplied by n minus 3. Everything equals to 3 over 1. So if it multiplies, this is the same as saying n minus 3 over 2 is equals to 3 over 1. So if you cross multiply now, this will now be n minus 3 is equals to 6. So yeah, n will now, if minus 3 goes here, it will now become positive. So 6 plus 3. So n will become 9. So that is the value of n. N is 9. Good. So it makes sense. You can check to see if you are correct, right? You can check. Always check to confirm you are correct. But, right? So go back to the question. If you fix 9 here, so the coefficient of 4 and that of 3, what will it be? For x to be 4, it means that you are, what term would that one be? That will be the third term. That will be the third term, right? So x to the, so if you fix 9 in that equation, you have the equation to be like this: 1 plus 2x to the power of 9, right? So remember what your first term is, what your second term is. Your first term is just 1 to the power of 9. Your second term will now be something n combination 1. So the for x to be 4, or for x to be 3 first of all, so that would be the that would be n combination 5. So let's go. Let's see. That should be it. N combination 4 will give us that cube. So n combination 4, if we now do 1 to the power of, remember, this will now be 9 minus 4, which is 5. Then 2x will now be to the power of 4. Okay. Yes. Yes. So n combination 3 will be 1 to the power of 9 minus 3. That is 6. Then 2x to the power of 3. Good. So our n is 9. Don't forget. So 9 combination 4, what would that be? 9 combination 4. Print your calculator to tell me the result for 9 combination 4. Yes, I want to test it so that you see what we are saying. 9 combination 4. So hold on. I want to use my calculator. So 9 combination 4 is 126. 1 raised to the power 5 is still 1. Then 2 raised to the power 4 is 16. Then you have x to the power of 4. Then Let's divide. So 9 raised to 9 combination 3 is 84. Then 2 raised to power 3 is 8. Then you have x cubed. Good. So now we don't have time to waste. So let's divide all of these numbers now. Okay. Let's go. 8 can go in 16 2 times. So this is gone. Then 2 can go in 84 how many times? 84 divided by 2 will give us 42, right? So this will be 42. Good. So, and 42 year 1, 42 year 3. So you can see you have 3 over 1, which proves that this is 3 ratio 1. You can see it. So that's it. So it means that our value of 9 that we obtain is absolutely correct. So, but if you don't know how to do it in the exam, please just know that your answer is correct anyway, but it's good if you can always check to see if your answer is correct by proving it. Most questions are like that in combination. Let me take out this portion. Now let's look at this question. Very interesting one. All right. So we're given that g of x has 2x plus 1 as a factor. Now, if g of x is divided by x minus 1, okay, board is back. Let me take this up. Oh. Let's just be patient with our board. Okay. All right. Now, we're given that g of x has 2x plus 1 as a factor. Now, if g of x is divided by x minus 1 and x minus 2, the remainder are minus 6 and minus 5 respectively, find the third term when, okay, this is another question. So let's treat this first one, right? So now I'm going to make a comment that since 2x plus 1 is a factor and g of x is a quadratic polynomial. Are you with me? Right? So want to use the remainder theorem. Therefore, using the remainder theorem, I am going to put x minus 1 to be 0 so that my x will be 1, right? So it then means that g of x is the multiplication of 2x plus 1 multiplied by a linear factor like ax plus b, right? That's what it means. Or you can start by telling us that let g of x be 2x plus 1, then ax plus b. That clear? So now that x is equals to 1, now what is g of 1? So anywhere I see x here, I'm going to put 1. So this will now be 2 times 1 plus 1, 8 times 1 plus b. Now it has a remainder, right? Is it not so? Do you remember? It has a remainder. And the remainder here is minus 6. So therefore, 2 times 1 is 2, plus 1, that's 3. Open bracket. 8 times 1 is 8, then plus b equals to negative 6. So I can divide, 3 can go in both sides of the equation. 3 we cancel 3. So 3 here goes here 2 times. So here I have a plus b to be negative 2, right? So let's make that equation 1, right? So I will make a plus b to be minus 2. That's equation 1. Then similarly, right? The other factor is x minus 2. I will now put x minus 2 to be 0. Therefore, x will be 2. So that if I say that my g of 2 will now be 2 times 2 plus 1, close that bracket, then a is still a multiplied by 2 plus b, close that bracket. The remainder here says minus 5. So if you simplify this, 2 times 2 is 4. 4 plus 1 is 5. Open bracket now. In the next bracket, this will be 2a plus b equals to negative 5. So looking at this, what is our A and what's our B? Yeah, 5 can cancel 5 in both sides. So this is negative 1. So therefore, you have 2a plus b equals to minus 1. So let's bring the two equations together. So yeah, this is 2a plus b, that's minus 1. That's equation 2. So let me write equation 1 under equation 2 so that we can proceed using elimination method. So if I have a plus b to be minus 2, that's equation 1. So I can say equation 2 minus equation 1. So 2a minus a is a, b minus b is 0, minus 1 minus minus 2. This is it, minus 1 minus minus 2 become minus 1 plus 2, which is the same as 2 minus 1, which is 1, right? So our A is 1. So let us now get the value for P. So to get B now, I'm going to say put 1 for A into any of the equation. Let's put it in equation 1. Therefore, it will now be 1 plus B equals to minus 2. Hence, okay, let's just get our B directly here. If 1 crosses to this side, it becomes minus 1. So minus 2 minus 1 becomes minus 3. So hence our A is 1 and our B is minus 3. Good. So that is A and B. But looking at the question, I believe they want us to get quadratic expression. They want us to get G of X. So G of X, remember we formed 2x plus 1. So we can now say hence G of X, yes, so let's go. Hence G of X which is 2x. What was the question we're given? Okay, 2x plus 1. That's it. Then said ax plus b. Good. So will now become 2x plus 1. Then a is 1. So 1 times x is x. Then our b is minus 3. Minus times plus is minus. So if we now multiply this, 2x times x is 2x squared. 2x times minus 3 is minus 6x. Then you take positive 1, multiply x, you get positive x. You take this x, multiply minus 3, you get minus 3. By further simplification, this will now become 2x squared. Minus 6x plus x is minus 5x plus 3. Right? So this is the quadratic expression. So remember, we were told that x minus 1 and x minus 2 are factors of this. Right? So can we test it? Yes. And we'll get a remainder. Right? Now let's test it now. If x is 1, we'll remember we said that put x minus 1 to be 0 to get x to be 1. Is that not so? So let's go back and put x to be 1 in that and see if we are going to get the remainder of minus 6. Then if we put x minus 2 to be 0, we'll get x to be 2. If we put x to be 2, do we get minus 5 in that quadratic equation? Let's try it and let's see if we are correct. So that's one way to test if your answer is correct. So let's go. So I want to slot in 1 in this x squared. Let's see what I would get. So let's check. This is our checkbox. So 2 times 1 squared minus 5 times 1 plus 3. 2 times 1 is 1 squared is 1 times 2 is 2. Minus 5 times 1 is 5. Then plus 3. Right? So, oh, sorry, this is minus 5x minus 3, not plus 3. I was wondering that where is this leading us to? Thank God we said we should check. Would have not seen that we wrote something. You can see this is minus. I changed it to plus without knowing. So that's why it's good to always check. Cross-check your work. Good. So let me write the minus very well. Good. So let me write it well now. Minus. So So 2 minus 5 is minus 3. Minus 3 and minus 3 is minus 6. So you can see that is correct. Special activate. Good. So this is minus 6. Good. So let's check for 2 when x is 2. So I'll change this 1 to 2. Change this to 2. 2 squared is 4. 4 times 2 is 8. So this becomes 8. Let me rub off on this side. Okay. So 2 squared is 4. 4 times 2 is 8. Minus 5 times 2 is 10. Then minus 3. 8 minus 10 is minus 2. Then minus 2 and minus 3 is minus 5, which is also correct based on the instruction given to us in the question. So here is the activities that you are meant to do if you thoroughly understand what we have done. So, I think it's just one question. Let me see. Or is it 2 questions? So you are going to expand this separately, Then, using the expansion in 1, use it to find the value of this. So this will now be, look at the model, 1 plus 2x. So this will be 1 plus 0.1. Sorry, 1 plus 0.2. Then here, 1 minus. So this will now be 1 minus 0.2 to give you this. So you will now do all your evaluations and arrive at your answer. So, and since this is to the power of 7 to the power of 7, we are going to have 8 terms. Then I think there's a second question. Maybe due to the, okay. There's a topic here, matrices and determinants, right? So, we will not be able to take this because of time, right? The other topics would have loved to treat, but for the sake of time, we'll not be able to take them. So I wish you well in your exam. And with what we have done, I am super sure that if you meet questions like this in the exam, you'll be able to tackle them. And not just tackling them, you'll be able to tackle them very well, right? So, with this, we've come to the end of today's class. We'll meet again. Our math class will be on the 30th and the 31st of this month. It's going to be on a Saturday and Sunday. 30th is a Saturday, then 31st is on a Sunday. So we are going to be solving past questions involving mathematics. And I believe the experience will be better than what we have in further maths, both in terms of attendance and our questions as well. All right, till we meet for our mathematics class.